Everyone. Welcome to Friday Happy Math Hour. Today we're going to continue with our topic of matrices. And last week we started to talk about matrices. And so today we're going to talk about multiplying matrices together. Then we're going to jump into do the inverse of a matrix. And then from there, if we have time, we'll go into determinants. And so let's continue. I'm going to go ahead and go to the slide that we need to get to. If you weren't here last week, we covered most of these slides, and so you can download the PowerPoint or watch the video from last week as well. So let's see, what page is it on? And we're almost there. Okay, so we're going to start with multiplication of matrices. And so if you want to multiply two matrices together, then it's important to look at the number of rows and columns for each of those. So in order to multiply the first matrix, you want to look at the number of columns, and the second matrix, you want to look at the number of rows. If they are the same, then that means that we can multiply the two matrices. If they're different, then we would not be able to multiply them. Now the outside numbers, the number of rows for the first matrix and the number of columns for the second matrix, that's going to be the result or your product, the size of your product, which would be m by p. Okay, so it's important again to look at the number of columns and the number of rows for your matrices to determine if you can multiply or not. So if we look at this first one, we have 4, 1 is our first matrix, and we're going to multiply it times 1, 2, which is our second matrix. So the first thing we want to do is write down the order, which is the size. And again, the size is determined by the number of rows. So this one has 1 row and 2 columns. And this one has 2 rows and 1 column. And so if you notice here, the number of columns in the first matrix and the number of rows in the second matrix are the same. That means that we would be able to multiply it. Now the outside numbers are going to give you the size of your matrix. So if we want to multiply, then what we do is we take that first row and we're going to multiply it with the first column, and then we're going to multiply the corresponding entries. So 4 times 1 would be 4. And then what we're going to do next is we're going to multiply 1 times 2. And then we add the two products together. So 4 times 1 is 4. 1 times 2 is 2. If we add those together, then we get 4 plus 2, which is going to be 6. So that would be our answer. Okay, so let's look at letter B. So first, let's see if we can multiply. This is a 2 by 1. This is a 1 by 2. Notice that we have the inside numbers are the same, so the number of columns is the same as the number of rows. So that means we can multiply the outside numbers. That's the size of our product. So in this case, we're going to get a 2 by 2. So we're going to take the first row, which is this one here, with the first column. And notice that the column only has one number. And so we take 1 times 4, and that's it. There's nothing below it. So the only answer here would be 1 times 4, which is going to be in this position. Then once we multiply by this column, we're going to go to the next column. And so now we're going to do 1 times the next column, which is 1. So now we have 1 times 1, so that's going to be that position. There's no more columns, so we go to the next row. So the next row here is the 2, and we start over with the columns. So 2 times 4, that's going to be our third number here. And then we go to the last column, 2 times 1. So we get 2 times 1, and then if we simplify, we get 1 times 4 is 4, 1 times 1 is 1, 2 times 4 is 8, and 2 times 1 is 2. And so this is going to be your result, your product. We have a couple of more that we can practice. find a squared, where a is equal to 3, 1, negative 1, and 2. So first, we want to know what a squared is. A squared is the same as a times a. So if we write down the matrices, we have the same matrix. I'm going to write down the order. So 2 by 2 and 2 by 2. So the numbers on the inside, which is the columns and rows, are the same. And the outside would be our product, which is 2 by 2. So we're going to take the first row. Let me go ahead and click next. So here's my first row with our first column. So we're going to do 3 times 3 plus 1 times negative 1. And that's going to give us our first number for the first position. And then we go to the second column. So we have 3 times 1 and 1 times 2. So that would be our second number. There's no more columns, so we go to the next row. So now we have negative 1 times 3 and 2 times negative 1. And we go to the last column, negative 1 times 1 and 2 times 2. So if we simplify, we get 3 times 3 is 9. 1 times negative 1 is negative 1. 9 plus negative 1 will give me the 8. And then the second number is 3 times 2. So 3 plus 2 is 5. And then we have negative 1 times 3, which is negative 3. 2 times negative 1 is negative 2. If we add these, we get negative 5. And then the last one is negative 1 plus 4, which would be 3. Okay, so that is multiplication. And we have another one here, so let's go ahead and write it out. So go ahead and write it out. So the B is 1, 0, 0, 1. A is 3, negative 3, negative 7, 0, 2, and 6. And so if you notice here, the number of columns is not the same as the number of rows. And so we cannot multiply these, so we say that it's impossible. And so that's what you would enter in your in WebAssign, impossible. So now I'm going to bring up the slide for the inverses. And let me go ahead and get it for us. Let's see. Which will actually start with multiplication again. Okay, so for the inverses, this is our inverse. So the definition is that if you take a matrix and you multiply it times the identity, which I'll explain what that is in a second, then if you get the identity, if you take a matrix, multiply it by its inverse, and you get the identity, but if you switch them around and put the inverse first times A, and you still get the identity, then we say that they are inverses of each other. Now the identity matrix is made up of ones in the diagonal and zeros everywhere else. So this is an example of a 2 by 2 identity, and this is an example of a 3 by 3 identity where we have ones in the diagonal and zeros everywhere else. Okay, so the symbol for inverse is this exponent of negative 1. So here it says show that B is the inverse of A. So in order to figure out if they're inverses, we need to multiply A times B, and we need to multiply B times A. And if we get the identity matrix, then they're inverses of each other. So first we'll multiply A times B. So I have listed it here. So we're going to do negative 1 times 1 is negative 1. And then 2 times 1 is 2. So if we add that, we're going to end up with 1. Okay, but I'm just listing it here, and then we'll simplify in a second. So now we go negative 1 times negative 2 is positive 2. And 2 times negative 1 is negative 2. Then we go to the next row. Negative 1 times 1 is negative 1. 1 times 1 is 1. And then the next column, negative 1 times negative 2 is positive 2. And 1 times negative 1 is negative 1. So if we simplify, we get negative 1 plus 2 is 1. 2 minus 2 is 0. Negative 1 plus 1 is 0. And 2 minus 1 is 1. So that gives us the identity matrix, but it's not good enough until we multiply B times A as well. So if we do the same process, then we also get the identity. Since they both give us the identity, then we can say that A and B are inverses of each other. Now, the goal for this section is going to be to find that inverse and then use the inverse to solve the system. So there are different ways to solving the inverse. And one of those ways is to write the matrix and attach the identity to it. Use row operations so that you end up with the identity first, and whatever's on the right side will be your inverse. Another way we can use is this formula here, but this is only good for a 2 by 2. If you have anything bigger, then you would want to go to this method. The third method is a method that is hardly used by instructors, but it's still a good method. And in fact, if you're comfortable solving systems using substitution and elimination, then this method might actually be a good one for you. I'm not going to focus on that one today. I'm going to focus on these first two. But if you're interested in seeing this method, then if you go to your ebook in this section, you'll be able to see an example of using this method. So the first method we're going to attach, so it says find the inverse of A. So we're going to attach the identity matrix. And so when I attach the identity matrix to the right side, then it looks like this. And now our goal is going to be to end up with the identity matrix first. And whatever's on this side, we're going to call that our inverse. So with my pencil, let me go ahead and just write out what our goal is, so that we can see a better view of it. So after everything, you want to end up with the following 1, 0, 0, 1, and then we're going to end up with some numbers here. And so this would be your inverse. Okay, but our goal is going to be to use row operations to get to this point. So we want to have a 1 here, and then we're going to make everything below it a 0. Then we go to the next one and make everything above it a 0. And so last week we did some examples on Gauss Jordan using row operations, so it's similar to that. So let's go ahead and work it out. So if you notice from our goal, we already have the one that we need there. So let me just write it out again. So we already have this 1. So that's a good thing. So we don't have to do much to make it a 1 because it's already a 1. But now I need to make whatever's below it a 0. So since they're opposites of each other, I could just add the 2 rows, row 1 plus row 2, and that's going to create a 0 down here. So symbolically, we can write it as row 1 plus row 2, and then we're going to put our answer in row 2. Okay, so 1 plus negative 1 is 0. 4 plus negative 3 is 1. And then 1 plus 0 is 1. And 0 plus 1 is 1. So now we have our 1, we have our 0. Our next goal is to make this a 1, which it already is. And so now we're going to use this 1 to make the top number 4 a 0. So in order to make this a 0, we're going to multiply 1 by a negative 4 and then add it to the positive 4 to make it a 0. And so symbolically, I can say negative 4 times row 2 plus row 1. Whatever we get, we put it back in row 1. Okay, so let me go ahead and do the work here. So negative 4 times 0 is 0, plus 1 is 1. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 1 is negative 4 plus 1, negative 3. Negative 4 times 1, negative 4, plus 0 is negative 4. And so if you notice, now we have our 1s and our 0s here. So that's our identity matrix. That means that whatever's on the right side is going to be our inverse. So we can write it out as A inverse is equal to negative 3, negative 4, 1, and 1. Okay, so this is the first method. Most of my students like the second method, and maybe you'll see why in a second. But let's go ahead and go to the second method. So the second method uses a formula. So it gives you a matrix A, B, C, D. And it says if you want to find the inverse, we're going to go 1 divided by A times D minus B times C. Then we're going to switch the A and the D. We're going to switch them to D and A. And then for B and C, we're going to change the signs. So if you have a positive, you make it negative. If it was negative, you would make it positive. And if you notice, this is the same example as the one before. Same example. So we should end up with the same answer. And so we're going to write it out. Just in section 8.5, when we talk about determinants, this bottom part here is your determinant. But we'll get to that later. Okay, so here's my matrix. And if it helps, you can write your ABCD here. And we're going to substitute those values into the formula. So we get 1 divided by A, which is 1, times D, negative 3, minus B, which is 4, times C, which is negative 1. Notice that I switch my A and D. So now instead of having 1, negative 3, I have negative 3, 1. And then I'm going to switch my signs. So B is positive, so I'm going to make it negative. And C is negative, so I'm going to make it positive. Now we're going to simplify. So 1 times negative 3 is negative 3. And then negative 4 times negative 1 is positive 4. Negative 3 plus 4 is 1. And 1 divided by 1 is 1. So 1 times the matrix would just be itself. So this is our inverse. Okay, let's try another one. It says use any method to find the inverse. So you can use any method. I'm going to go ahead and use the formula. So here I have my formula. I'm going to substitute my values for the first one. So we're going to have A times D, which is 3 times 2, and B times C, which is negative 1 times negative 2. So we have, and then we're going to switch our A and D. So D, instead of 3, 2, I'm going to have 2, 3. And then instead of a negative, I'm going to make it positive. Instead of negative, I'm going to make it positive. So let's simplify. 3 times 2 is 6. And then we have a minus negative 1 times negative 2 is positive 2. And then we have our minus. 6 minus 2 is 4. And now the 1/4 is a scalar, which means we multiply everything by 1/4. So 1/4 times 2 is 2/4. 1/4 times 1 is 1/4. 1/4 times 2 is 2/4. 1/4 times 3 is 3/4. And so then we reduce, so 2/4 would be a half. And then we have 1/4, a half, and 3/4. So that would be our inverse. And then the last one here is same idea. We're going to multiply 3 times 2 and negative 1 times negative 6. And then I'm going to switch the 3 and the 2. So now I get 2, 3. And I'm going to switch the signs for negative 1 and negative 6. So now we have 1 and 6. Okay, so 3 times 2 is 6. Negative 1 times negative 6 is 6. And 6 minus 6 gives us 0. So here we cannot divide by 0 because it would be undefined. So then that means that this matrix does not have an inverse. So we say that A is not invertible. So it does not have an inverse. Now for this bigger matrix, we cannot use the formula because it's not a 2 by 2. So in this situation, we would have to attach the identity. If your instructor lets you use a graphing calculator, then you could use the graphing calculator to find the inverse. But not all instructors allow the calculator, so we'll just work it out. So again, we're going to attach the inverse. So I've attached the inverse here. And then my goal, let me write my goal up here so we can see it, is to have the identity matrix first. Okay, so we want to work on having a 1 here first, which we do. And now we're going to use this one to make everything below it a 0. And so if we look at our matrix, we have our 1, so that's good. Now we're going to make this a 0. Well, in order to make this a 0, we can add the rows if they have opposite signs. So first I'm going to take -1 times 1, and if I add it to 1, then I end up with a 0. So what we're going to do symbolically here is we're going to multiply -1 times row 1, and then we're going to add it to row 2. Okay, so -1 times 1 is -1, plus 1 is 0. -1 times -1 is +1, and then plus 0. And so let me click on the slide so you can see as we're working it out. So let me start over. -1 times 1 is -1 plus 1 gives us a 0. -1 times -1 is +1 plus 0 gives me a +1. -1 times 0 is 0 plus -1, -1. And you want to keep doing this all the way across. So we get -1 plus 0, -1, and then -1 times 0 is 0, plus 1 is 1, and -1 times 0 is 0, plus 0 gives me 0. Now the first row and third row, we don't want to change those. Here it's changed because we also are going to get rid of this 6. How am I going to get rid of this 6? We're going to multiply -6 times 1, and then we're going to add it to that last row. So -6 times 1 is -6, plus 6 is 0. And -6 times -1 is +6, plus a -2. And let me see here. It's going to be +4. And then -6 times 0 is 0, plus -3 is -3. -6 times 1 is -6, plus 0, -6. And -6 times 0 is 0, plus 0 is 0. And the last one, -6 times 0 is 0, plus 1 gives me a 1. So far, I have my 1, my 0, and my 0. And so now what we want to do is continue the process. And so in our goal, next time I should write my goal here in every slide. That way we don't have to keep writing it. Okay, so now we already have this one, so that's good. Now we're going to work on making this a 1. And if you notice, it's already a 1, so that's perfect. Okay, so now we're going to use that one to make this top one a 0 and the bottom a 0. And so we're going to use row operations again so that we can change that. Okay, so let's go on. So what we're going to do, so I just brought this matrix and I put it down here. And so what we're going to do is, here's my 1. I need to make this 4 a 0. So I'm going to multiply this 1 by the opposite of what's down here, which is -4. So -4 times 0 is 0, plus 0 gives me 0. -4 times 1 is -4, plus 4 gives me 0. -4 times -1, +4, plus a -3 gives me a 1. And -4 times -1, +4 plus -6 gives me a -2. And -4 times 1 is -4 plus 0, -4. -4 times 0 is 0, plus 1 is 1. And then we also need to make this a 0. But notice they already have opposite signs. So all we have to do is add row 2 plus row 1. So 0 plus 1 is 1. 1 plus -1 is 0. -1 plus 0 is -1. -1 plus 1 is 0. And 1 plus 0 is 1. 0 plus 0 is 0. So now we have our 1 here, 0's below it. We have a 1 here, 0's above and below it. So our next step is to make this a 1, which we already have a 1. And I need everything above it to be 0's. The good thing is, if you notice, we have a +1 and these are -1s. So they're already opposites of each other. So all we have to do is add the rows together, and that will help us get rid of, make them 0's. So I put my bio here, so I'm going to add them. So let's do the first one. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is 0. Negative 2 plus 0, negative 2. Negative 4 plus 1, negative 3. 1 plus 0 is 1. And then let's do the second one. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus negative 1 is 0. And 2 plus negative 1, negative 3. Negative 4 plus 1, negative 3. And 1 plus 0 is 1. And so now we have our identity matrix on the left. So our inverse is going to be, let me go back. So our inverse, we can write it as A inverse is equal to negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, and 1. So this is our inverse. Okay, so that takes a few minutes, right? So sometimes using technology can help, but of course, it depends on your instructor. So what is the whole point of the inverse, right? I mean, we just went through all that, but what are we going to use it for? And so a lot of chapter 7 and chapter 8, we're just trying to solve a system. So remember, just to refresh our mind, we have a system could look something like this: x plus y equals 8, and 2x minus 3y equals 10. And so in chapter 7, we saw the substitution method, we saw the elimination method. Last Friday we did the Gauss-Jordan elimination with matrices to solve a system like this. And so now with the inverses, it's another way to solve the same system. So you might be asking yourself, well, why do I need to know so many ways? Sometimes, some people prefer the matrices, some people prefer to use the substitution elimination method. But whenever you have bigger systems, like let's say you had 3 equations or 4 equations or 5 equations, then matrices might be a lot quicker to use than solving them by substitution or elimination. Okay, so if we want to use a matrix, an inverse, then this right here is your formula. So in order to solve a system, you're going to have to take the inverse and multiply it times b. So what does x and b represent here? So A inverse, of course, that's your inverse. B is your constant matrix, and x is your variable matrix. And I think I might have an example over here. Let's go to the next slide. All right, so let's say you have this matrix. So it says use the inverse. So they already gave me the inverse. So that means I don't have to go and look for it because it's already given. So just to help us out, I'm going to go ahead and write it as A inverse is equal to negative 8, 3, negative 3, and 1. So the other thing that we need is B. B is made up of your constants. What are the constants? Remember, those are the numbers that don't have a variable attached to them. And then x is your variables, x and y in this case. Okay, so in order to solve for your variables, we're going to need to set up this equation, A inverse times B. So in order to continue, we're going to figure out what our B matrix is and what is our X matrix. Okay, so let's go on. So my B matrix are my constants 4 and 12. My A matrix are the coefficients of 1, negative 3, 3, and negative 8. And my X matrix is my variables X and Y. The reason I put A here is because you're not always going to be given an inverse. So if you don't get the inverse, you're going to have to find it ourselves. So in this case, A inverse is already given here. So we set up our formula. So we have X, which is X and Y. Our inverse was given, negative 8, 3, negative 3, and 1. And then B is 4 and 12. And so now all we have to do is multiply those two matrices together. So negative 8 times 4, two matrices together. So negative 8 times 4 is negative 32, and 3 times 12 is 36. So we're going to add negative 32 plus 36 gives me 4. And then we go to the next row. Negative 3 times 4 is negative 12. 1 times 12 is positive 12. Negative 12 plus 12 is 0. So what I can take from here is that x is equal to 4 and y is equal to 0. Okay, let's try one without the embers. So it says solve the system using the embers. So first, identify your a, b, and x. So my a is 1, negative 5, 5, and negative 24. And my b is 27, 128. And x and y is my variables. So in order to continue, I need to know what the inverse is. So I'm going to use the formula a inverse is equal to 1. And we're going to multiply 1 times negative 24 minus negative 5 times 5. And then remember, we switch the 1 and negative 24. So we write negative 24 and 1. And then we're going to switch the sign. So instead of negative 5, it becomes a 5. And instead of 5, it becomes a negative 5. So if we simplify, 1 times negative 24 is negative 24. And then we have minus negative 25. Simplify further. So we get negative negative is positive here, which will end up with a 1. And 1 times the matrix is itself. So now we have our inverse. So we can set up our formula. So we have our inverse times b. And we're going to need to multiply. So to multiply, we take negative 24 times 27 plus 5 times 128. And then negative 5 times 27 and 1 times 128. So if we multiply this out and simplify, negative 24 times 27 is negative 648. 5 times 128 is 640. If we add them, we get negative 8 and negative 7. So my solution is x is, let me go back. X is negative 8 and y is negative 7. Okay, so that's using the inverse. So this one here is a 3 by 3, and they already gave us the inverse, so we don't have to find it. So we just set it up the same way. So we take the inverse, which was given, our constant 0.63, and we're going to multiply. So 1 times 0 plus 1 times 6 plus negative 1 times 3 gives us positive 3. Negative 3 times 0 is 0. 2 times 6 is 12. Negative 1 times 3 is negative 3, so we get 9. And then 3 times 0 is 0. Negative 3 times 6 is negative 18 plus 6. We get negative 12. Okay, so now to introduce the matrix, the determinants. The determinant is basically taking your matrix here and multiplying across, so A1 times B2 and B1 times A2, and subtracting them. So that is what we do for the inverse for the in the formula when we have 1 divided by, let me write it out. Let me get my pen. So when we're doing the inverse in the formula, remember we have 1 divided by AD minus BC. Well, this part is the same as this part, okay? And we call that the determinant. So the symbol for it, it's the absolute value sign here, or you can write it as DET parentheses A. But when you have your matrix, notice we changed the brackets to these straight lines. Then we multiply and subtract. So let's try an example. So for letter A, we have the determinant of A. So we're going to multiply 2 times 2 and negative 3 times 1. So I wrote it down here. So 2 times 2 is 4 and negative negative is positive 3. So our determinant is 7. For B, we're going to have 2 times 2 and 1 times 4. So we get 2 times 2 minus 4 times 1. So we get 0. If your determinant is 0, then that means it has no inverse. And then letter C, we're going to have 0 times 4 and 3 halves times 2. So we get 0 minus 3 is negative 3. But what if it's something bigger than a 2 by 2? So if it's bigger than a 2 by 2, then we're going to need to do the following method. I'll come back to the cofactors here. Let me see. Okay, so if we want to find the determinant of a 3 by 3, then this is how we would work it out. So first, we're going to find what we call the minors. So I start with the first number. I'm going to circle it, and I'm going to cross out that row and that column, or this column and this row. And if you notice, what I have left in here is a 2 by 2. So I'm going to call that M11, and the reason it's 1, 1 is because it's the first row and the first column that I crossed out. Okay, so now we find the determinant for that. Negative 1 times 1 minus 2 times 0 is negative 1. So then we go to the next one. So I'm going to move over to the 2. I'm going to circle it. I'm going to cross out that row and that column. And so now this one's called 1, 2 because we crossed out the first row, second column. And if you notice, we're left with 3, 4, 2, and 1. So we do the same. 3 times 1 minus 4 times 2. So we get 3 minus 8 is negative 5. And then we go to the 1. And then we go to the 1. And we do the same thing. So we are left with 3, negative 1, 4, and 0. Notice it's called 1, 3 because that's the first row, third column. And we end up with 4. Okay. So then we go down on the first row, the first column, and we cross out the first column and the second row. And now we're left with 2, 1, 0, 1, and we get a 2. And then we cross out the next one. And so then we get 0, 1, 4, 1. So we're basically crossing out all of these, right? So we can get all the 9 minors. Okay. So we continue the process, then we end up with negative 8 and negative 6 for the last 2. Once you have your minors, then we're going to use cofactors. And all this means is that we're going to take our minor times our cofactor here. So negative 1 times a positive is negative 1. Negative 5 times a negative, positive 5. 4 times a positive is positive. 2 times a negative is negative. Negative and positive will be negative. Negative and negative will be positive. 5 times a positive will be positive. Negative 3 times a negative is positive. Negative and positive is negative. So these are cofactors. Now to get the determinant, let me go back. Then what we're going to do is we're going to multiply. You can pick any row or any column and multiply. So here I picked, let's use a 0 times a negative 1. That's right here. Plus 2 times the 5 and 1 times the 4. And if I simplify here, I get 10 plus 4 is 14. But I could have also used this row or this row, and I'm still going to end up with the same number. Okay. Now, if you use technology, then you would enter the matrix and you would use the key for determinant, and it would give you the 14. Okay. So if your instructor doesn't let you use technology, for example, for an exam, but if you're working on homework and you do all this by hand and you want to check your work, Decimals also has a good matrix calculator that you can check your work with. But I do encourage you to do it by hand, especially if you're not allowed to use the technology. Now, why do we care about the determinant? So that's the big question again, right? So now, just to kind of summarize what's been going on, we have, if we have a system, let's say you have this, right? Then in chapter 7, you had substitution, you had elimination, and then in chapter 8, we had Gauss-Jordan. We had the inverse. And now we're going to have what we call Cramer's rule. Okay, but all of these are methods that you can use to solve a system. And so depending on which method you prefer, then those would be your options. Okay, so for Cramer's rule, I actually like Cramer's rule. Basically, you take your system and you're going to need a coefficient matrix, which are all the numbers in front of the variables. So in this case, A1, B1, A2, and B2. Then we're going to find the determinant of this coefficient matrix. And then we need the determinant for, we call it dx. And so for dx, what we're doing is we're replacing the a's here by the constants. Okay. And then for dy, we're going to replace the b's with the constants. To get your final answer, then we divide dx divided by d and dy divided by d. So let me walk you through an example. So let's say we have this system. First thing you want to do is figure out what these different matrices are. So the first one, the coefficient matrix, would be 4, -2, 3, and -5. So I listed here. Then I need to know what D is. D is just going to be the determinant of my coefficient matrix. So 4 times -5 is -20. -2 times 3 is -6. Negative is positive. So we get a -14. Then we need dx. So let's write dx. So instead of a's here, we're going to write the constants, which is 10 and 11. And then our y's are still -2, -5. Find the determinant, 10 times -5, -2 times 11. We get -28. And then the last one, we're going to do dy. So we're going to replace the b's with the constants. And so it will look like this: 4, 3, 10, and 11. 4 times 11 minus 10 times 3 gives me 14. And now we can set up x is equal to dx divided. We can set up x is equal to dx divided by d, and y is equal to dy divided by d. So dx was 28, d was -14. If we divide -28 by -14, we get a +2. And for y, we have 14 divided by -14, so we get -1. So our solutions are x equals 2 and y equals -1. Okay, so that is the last slide. And so this kind of covers all of chapter 8. And so I think this is next week. There's no Friday Happy Math Hour. And then after that, I think we have one more, which would be the review for the final, I believe. But that's it for today. And so I wish you all a very happy Thanksgiving, and enjoy whatever meals you eat. I know some people make steak, some make turkey, some make ham. Whatever it is, enjoy it. And I'll pass it back over.
Thank you, Ms. Chuka, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take the time to fill out the survey. Like Ms. Chuka said earlier, we will not be back next week, but the following week. Okay, that'll be December the 6th. And at that time, we will have the presentations on Math 1314 and Math 1324, which will both be covering the final exam review. So make sure that you tune back in. Also today, we will be having the student success, which will be covering the topic of EPCC culinary arts. And for our final presentation will be on December the 6th. We will have another great presentation. Hopefully you guys could join us. It'll be how to improve your credit score, which will be presented by Mr. Enrique Lechuga. Thank you all for coming in today. We hope you all have a lovely weekend. Please, like Ms. Chuga said, enjoy your time with your family and your meals. If you guys have any questions, feel free to use the chat box or mic. Thank you all again for coming in. To